Now, if you come back here, I go back to the temperature setting screen, you can see we have different zones. Now, each zone means there is a heating band. So, if we come back to the unit, that basically means we have one and, well, we actually have more of these heating bands sitting beneath these covers. So, if you come a bit back, yep. So here, beneath this entire casing, there are multiple heating bands. So the material comes in from the end of the funnel, and it will be heated at a different zone and gradually melted until it reaches the end of the injection unit, right? So now, if you remember, we have already loaded some material in there, and we need to do purge. Now, to do the purge, we have to drive the material out of the barrel and see if there is any sign of trouble. So let me do that first. Now, if you pay attention to the bottom, to this area, you're going to see molten polymer dropping out. Okay, the machine stopped working, and this is the end of the purge. Now, if I grab the material, now these are molten polypropylene at the moment. It's very hot, so we're not going to touch it. And you can see it has this glassy texture. Now, one thing I'm looking at is, as it cools down, do I have like a dirty particles trapped inside? Now, there's a tiny little bit, but we don't see a lot. The second thing we're looking at is the overall color. Do I have like a dark, a brown, or red, different colors? Now, I don't see that. That means the polymer is overall good quality. There's no degradation, there's no burning. So that tells me the machine is clean enough, and now we can do the molding process for real. Alright, so let me get rid of this, and we're ready to do the next bit. Now, the next thing I'm going to do is we are going to shut this guard. Hold on a second. Oh, yeah. We're going to shut this guard because without the safety switch, it won't move. Before I do that, I'll just clean this a little bit. As you can see, there's a tiny bit still hanging there. I'll remove that. And now, close the guard. We will close this guard. And now everything is safe and ready. Now we're ready to go. Now, when it does the injection molding, it will go in the sequence like that's what I'm gonna say. First, this entire unit will move forward, and then the material will be loaded and then injected into the mold on the other side of this panel. And then the mold will close, and then the molten polymer will solidify in the mold, followed by injection. So we're going to see this in sequence. First I'm going to do is to load the material. Now you can't really see what's going on because it's all covered, but at the moment this is just loading up material, and the volume, if you remember, that will be 14.11. And now we're going to do the real molding. So the unit is moving forward. that humming noise means the injection is already taking place. Now if you come the other side, we're going to see the mold at the moment is closed. It will then open and a piece was ejected. Now we're going to see that again. The cold polymer, the molten polymer is going into the mold, filling the mold. That noise is the injector reloading again. Now the mold is going to open and a piece ejected. Now if you come down here, you can see this is a continuous process. Give it a few seconds and another piece will drop out. Yeah, so that is how we do injection molding. Now, I'll keep the machine going, and while it is still running, let's think about the specification. Just like when you buy the car, there will be like a different engine sizes, different displacement. Here is a very simple way to describe. Battlefield is the brand of this equipment, which can be anything else, but HM4130. Now this is a very general way to describe equipment. HM means this is a hydraulic machine. It's driven by hydraulic mechanisms, and it gives you a smooth, continuous process, less jittering, less vibration, and basically gives you better finishing and better quality of your sample. 40 and 130. 40 is a tonnage, which is called a clamping force. So if you remember, the mold has to open and close. Now, you don't want that mold to have any leak. That's the reason why you need to apply clamping force. Now, for this machine, we have clamping force of 40 metric tons. That means the maximum force can be applied to a mold will be 40 metric tons. Now this is actually a very small number. If you go to industry, that number will go very high, and it's basically proportional to the size of the mold you're using. Now talking to the size of the mold, we come to the next number, 130. Now 130 is the volume or the maximum volume this machine can give you. So in this case, it's 130 milliliter or 130 cc. Now, if you remember, previously I talked about the volume per shot of what we're doing at the moment. That was 14.11. So we're basically at the moment running about 10% of the maximum volume it can offer. Right? Now, if you think about these two numbers, in industry there can be equipments making pieces or objects the size of your door, the size of your car panel. Then obviously that 40 can go to hundreds, if not thousands, and this 130 will no longer be cc's. It could be 130 liter by volume. So this is a very general way to identify different types of injection molding machine. All right. Now this, if you come back to here, now this basically concludes the equipment demonstration part. So what I will do, I'll put it in final step, so it will finish the last cycle and just stay there. And now let's turn around and have a look at some other samples. Now, if we start with here, this piece, you can see it's a molten, it's a lump of molten polymer, or now solidified. However, this is a failed purge. By failed, I mean inside you can see clear sign of dark particles, soot-like bits and pieces, and this means there is serious contamination inside the injection unit. And if I see this at the beginning of this run, I will actually do multiple purging processes and make sure the material comes out is clean without contamination, then proceed. Right? So this is typically what we see with a failed purge. It doesn't look clean. Now, on this table, you can also see there are various different samples. These are all defective samples. Now, if you download this video, there will be other documents like PDFs attached to this video where we'll give you a more detailed description. Here are just a few examples to show you what are the common defective samples can be and how they look like. Let's start with this one. This one's called short shot. Now, the sample here I'm pointing, that is basically how it's supposed to be. And then we get this one. Now, apparently something's missing here. And that is because we don't have enough material going into the mold. And therefore, it fell short. And that's why it's called a short shot. Now, this has nothing to do with temperature or pressure or anything like that. This is simply an error of material, the amount of material you put in. And then we come here, you're going to see the next one, bubbling or blisterings or any sort of internal voids. Now, this is going to be a bit difficult to see, so I have to manipulate it a little bit. If I borrow one of the samples from the previous batch, and if I put them right on top of it, this should be much easier to see. You can see the one here, it has a nice, clean, solid piece. And whereas the other one here, you can see in the middle, there's a string of bubbles or cavities. Now, the reason why you have that string of bubbles, and that is because inside you have moisture trapped in there. And because the moisture has nowhere to go, it turned into a bubble, and after the polymer solidifies, it gets trapped in there, becomes cavity. Now in this case, we can see it because the sample is semi-transparent. But what if you're molding something solid and opaque, and you can potentially have a lot of defects inside that you can't tell from the surface? And that is why, at the very beginning, I said moisture removal is very important. Now the next thing to do with moisture would be this sample is called a splay mark. Now if I move the light source a little bit,